Okay, so these are the 4 problems that we didn't really get to thoroughly do in class. So I want to redo them for you all here on this one video. So I'm going to go in order that we did in class. So I'm going to start with B, then go to C, then D, and then I'll finish up example A, and that'll be the order. So if you feel like this video isn't helpful, then just feel free to skip around or don't watch it and just do the green sheet. Hopefully that's helpful. So first I ask myself, what am I being asked to do? So in the concept of adding and subtracting, you can only add like radicals. And so what that means is this number under here needs to match. So when I'm adding and subtracting, I'm just looking for matching pairs. So 5 root 3 matches with this. And so basically you're just trying to put the stuff in front together. So 5 minus 8. So 5 minus 8 is negative 3. And the radical stays exactly the same because it's just like 5x's minus 8x's, negative 3x's. Or 5 hearts minus 8 hearts will be negative 3 hearts, right? So we're just putting together the stuff that's the same, and same stuff doesn't change. What changes is the amount of them, and the amount of them is dependent on the number in front. So I see another match here, and that's that root 7. So I've got that root 7 and another root 7. So again, I'm looking for these numbers to match, and then I just focus on the numbers in front. So I've got a positive 1 in front here and a positive 11. So 1 and 11 together, that's 12. So I have 12 root x's. Sorry, root 7s. If I have 1 root 7 from here and 11 of them over here, then together I have 12 of them. And that's it. That's all I've got to do in this kind of problem. This problem, on the other hand, is a little different. And so when you multiply like parts, and the numbers change. So here in this example, the radicals did not. The root 7 and the 7 stayed the same. Here, they're going to change. So we multiply the 10 and the 2, and I know that we're multiplying because the symbol in the middle, and that's 20. And then we've got a root. 3 times 3 is 9. So if I was adding this, 10 root 3 plus 2 root 3 would be 12 root 3. This is what happens when you add or subtract. You just focus on the numbers in front. But when you're multiplying, you multiply all the parts that are the same. So the root 3 multiplied by the root 3 gave me the 9. These two numbers multiplied is 20. And then if I have anything left to do, I finish it. And so what I mean by that is I know that root 9 is the same thing as 3. The square root of 9 is 3. And the connection here was multiplication, so I might as well just multiply it together, giving me my 60. So that's my final answer here. So again, we can do something like this. This again is a multiplication problem. It's distributive property, so we're going to take this here and multiply it by here. That's a little bit too large. By this. So again, when you're multiplying matching parts. So this is a whole number without a radical, and so is this. So 5 times 2 is 10, and there was no root to multiply with, so the root 6 just comes along. So 5 times 2 is 10, root 6. I'll do the same thing with that second parenthesis, or the second thing in the parenthesis. I multiply this times this. So if you notice, the parts that match are 2 times negative 4, so negative 8. And I have a root. Root 6 matches with this root 3. 6 times 3 is 18. So you would think that you might be done here, but there's actually a little bit more to do this problem because right now we're back to adding and subtracting. We can only add and subtract if these numbers are the same, and they're not. So let's go back to problem A, and I'll come back to that one in a second. The way that it's written makes it seem like it's not possible, but it actually is, because I can make root 75 turn into a smaller radical. So when the numbers are small, like 3, 5, 7, 11, it's nothing to worry about there, but when the numbers are bigger, perfect squares are embedded in them. So what's a perfect square? Perfect squares are numbers that you can square root. I know the square root of 4, I know the square root of 9, I know the square root of 16, I know the square root of 100, I know the square root of 25. I know lots of square roots. I have no idea what the square root of 3 is, or 7, or 18, or 11. So there are numbers that I can square root, and there are numbers that I can't. So what you're going to try to think of in these examples is, can you break apart 75 into two numbers that multiply to 75, but one of these numbers should be on the list. So I'm pretty sure 75 is just 3 25s. And I always put the number that I can square root in the front. So the square root of 75 is 25 and 3. See, 25 times 3 is 75. And the square root of 25 is 5. So now I've turned this and this into the same thing. And I promise you they're the exact same thing. If I go to Desmos and type in square root of 75 and 5 square root 3, JK, hold please. See, same exact answer, 8.66. So you can break apart these big numbers into two radicals where they multiply together, but one of the numbers has to be a number that you can take the square root of. If you don't know the square root of it, like this won't make any sense for lots of reasons. If this was 70 and 5, you can't do that because 70 times 5 isn't 75. So you have to pick numbers off the list. 15 times 5 is 75, but I have no idea what the square root of 15 is, and I have no idea what the square root of 5 is, so I'm not going to pick those numbers. 25 I do know, and 3, the two of these do make 75. So this turns out to be 5 root 3. Now, why is that helpful? Because if I bring down the minus root 3, you'll notice that now these radicals match. So remember, when you're adding and subtracting, the numbers underneath the root don't change. So what's secretly here is a minus 1. 5 minus 1 is 4, and that's my final answer here. So that takes me back to this problem. Sorry, my screen froze. That takes me back to this problem, where when you multiply 2 times 5, you get 10. Root 6 times nothing is just the root 6. 2 and negative 4 is negative 8. Root 6 and root 3 is root 18. Normally, these don't look combinable because these two numbers are not the same thing. But I wonder if they are. So root 18 can be broken up into two radicals. Two numbers that multiply to 18 are 6 and 3, but I don't think that's going to be helpful because I have no idea what the square root of 6 is. I have no idea what the square root of 3 is. So now I'm going to try different numbers. 9 and 2 work, I think, right? 9 times 2 is 18, and the square root of 9 is 3. So I can make this turn into 10 root 6. But what's the point, actually, now that I think about it? Because look at this, root 6 and root 2 are different radicals. So really, there's nothing else you can do, but it's always good to do these little things on the side. So that can just be my final answer like that. Okay, so that's all I got. Hopefully you can do the rest of the problems on here. I'm going to post the rest of the keys, so hopefully that helps.